So in this video, we're going to talk about the tangent and normal to a curve. Before we start that, we need to remember what is the equation of a line. So whenever we're talking about a tangent or a normal line, we need to remember the equation of a straight line. So the equation of the line is y equals mx plus b. M in this case, we call it the slope of the line. B is called the y-intercept of the line. So it's basically the y-coordinate of the point of intersection with the y-axis. In other words, when I say point of intersection of the line with the y-axis, it means the x of the point, the x-coordinate is 0. And the y-coordinate here in this case is b. So whenever we see a point in the form 0, b, we can call it directly a y-intercept, and the b value is equal to the y-coordinate of the point. Knowing this, if I have a curve and I have a tangent at a point here, let's say k. So this is the tangent to the curve at the point k. When I'm talking about the normal to the curve at point k, it means it's a perpendicular line to the tangent at the same point k. So this is t and this is the normal n. Alright, let's see some examples. Given the function y equals 2x squared minus 3x, they're telling you find the equation of the tangent and the normal at the point 1, -1. Now, instead of doing at 1, -1, they can give you only at x equals 1, and you are supposed to find the y value. Now, if I'm doing this question, first of all, I need to know what is the point I'm working with. So if you know the x value, because the point that we have, again, if I have this curve, the point we have, it's a point belonging to the curve, and it belongs to the tangent at the same time, and it belongs to the normal. So we're talking about the same point. So it's very helpful for us to find the coordinates of this point. Now, how do I do that? If x equals 1, because this point belongs to the curve, so I can substitute instead of the x's, the value of x we have. So in this case, we get 2 minus 3, which is -1. So I know that I'm working with the point 1, -1. Now, as we spoke before about the gradient of the curve at a specific point in the previous video, it's the same thing as the slope of the tangent line at that specific point. So in this case, the first step is to find the point. If it's already given to you, then you know no need to worry about it. If it's not, then you need to find it. The next step will be finding the derivative, and in this case we bring the 2 down, so 2 times 2 will be 4x. Whenever we have something of the form 3x, its derivative is only 3, so we get y prime equals 4x minus 3. Now, using the derivative, we can find the slope of the tangent. I'm gonna call it m of t, which is the derivative at the specific x value we have, which is 1. It means go to y prime, replace instead of x1, and this is how you get the slope of the tangent. 4 minus 3, and we get 1 to be the slope of the tangent. Once you get the slope, now you write the general form of straight line is y equals mx plus b. So I write y equals 1x plus b. No need to write 1x, you can just write it as x. Now my aim is to find b. Now as I said, this point belongs to the curve. I will label it in red. So this point where we have the tangent, it belongs to the curve and to the tangent at the same time. So we are allowed to substitute the coordinates of that point in the equation of the tangent. So what I will do is, I'll take the y value of this point, which is -1, the x value, which is 1, and I will find b from there. Now take the b to the other side, or take the 1 to the other side, you get -1 minus 1 equals b. It means b is equal to -2. Knowing this, now I can mention that the tangent by going back here and replace instead of the b -2. So the tangent line has an equation y equals x minus 2. If the question only find the equation of the tangent, you're gonna stop there. Now, let's say you have an extra part in the question where they're asking you to find the normal. Then you have to do the following. You need to remember that the normal and the tangent are perpendicular. So if I know the slope of the tangent, I can find the slope of the normal. If I know the slope of the normal, you can find the slope of the tangent. So whenever we have two perpendicular lines, if you know the slope of one, you can find the other one by doing the following. So I'm gonna call the slope of the normal line as mn equals, always the rule will be -1 over the slope of the other line perpendicular to it. So in this case, the slope of the normal is equal -1 over the slope of the tangent, which is -1. Slope of the tangent, we found it here. And in this case, it will be -1. Now, I write the equation of the normal. So whenever we find the slope, we write the equation of the line. Y equals, the slope of the normal is -1, so I will write -1 times x plus the new y-intercept. So this b is different than the previous one. That one is for the tangent, this one is for the normal. Now again, the red point, as we can see, it's on the normal line. So we are allowed to take the coordinates and replace them in the normal equation. So instead of the y, we replace -1. Instead of the x, we replace 1. And we solve. So -1 equals -1 plus b. We take this -1 to the other side, we get -1 plus 1 equals to b. In this case, b will be 0. So I go back here, replace the value of b, and this will be my final answer. So y equals -x plus 0. No need to write it, so it's just -x.